If A over B is rational number and if C is any non-zero real number, then A over B is equal to AC over BC. That is, the numerator and denominator of the rational number may either be multiplied or divided by the same non-zero number without changing the value of the rational number. So example, 15 over 20, if I break this to its prime numbers, would be 3 times 5 over 4 times 5. Notice that 5 over 5 returns to 1, so the whole thing would equal to 3 over 4. We've done this before. 3/4 is equal to 15 over 20. So step number 1 is to factor both numerator and the denominator to find the greatest common factor. Step number 2, apply the fundamental property. Divide out common factors. Let's take a look at some examples. We want to write each rational expression in lowest term. Here we have the top of the fraction, we have the second order equation, polynomial. So as the bottom, we need to factor these, see if we can reduce them. So do not cancel y squared, please. You need to factor them, right? Okay. So if you factor this, again, if you have problem factoring, go back to my previous lectures on how to factor. You get into y plus 3 times y minus 1. You factor what you have at the bottom of the fraction, you get y minus 2 times y minus 1. Factoring this actually would be easier now, because once you factor one of these polynomials, that should give you a hint as what might be the factor for the other one. Since I have y minus 1 here, most likely I might have y minus 1 at the bottom of the fraction. So you can see that y minus 1 over y minus 1 turns to 1, and then the whole thing turns out to be y plus 3 over y minus 2. Okay, number 2, you have second part, B, would be y plus 2 over y squared plus 4. Well, doesn't look like this is factorable, so the denominator cannot be factored, so this expression cannot be simplified. That's the lowest term already. Part C, you have 1 plus p cubed. That's sum of cubed. You need to remember the formula. If you have a problem factoring sum of the cube, please refer to the previous lecture on sum of cubed. And here you get 1 plus p times 1 minus p plus p cubed. And then, as you see, 1 plus p reduces. You really need to go back and practice your factoring if you have a difficulty with that. In this section, we're assuming that you already know that part. Write each rational expression in lowest term. Here we have r minus 1 over 1 minus r. Looks kind of the same, except if I factor a minus 1 out of either of these two terms, I can make them exactly look alike. So if I factor a minus 1 at the bottom of the fraction, see, what times minus 1 give you 1? They give you negative 1. What times minus 1 give you the second term? So in this case, I can either factor a minus 1 at the top of the fraction or minus 1 at the bottom of the fraction. Let me go ahead and factor a minus 1 at the top of the fraction, see what happens. If I factor a minus 1, what times minus 1 give me this first term? It would be r, right? Or negative r. It would be minus r. Minus r times minus 1 give you r. What times minus 1 give me the second term? Would be plus 1. Right? If I distribute this, you can see that, right? Minus 1 times minus r give me plus r. Minus 1 times plus 1 give me minus 1. You notice that I'm not multiplying this by negative 1. I'm just simply factoring minus 1 out. By doing that, you notice that minus r plus 1, that really is 1 minus r. If I switch these two terms around, that's the same as 1 minus r. That's how you can reduce this that turns everything equal to minus 1. And if you did factor a minus 1 out of the bottom one, it results into the same expression. So you want to keep in mind that if you have a minus b, that would be the same as minus b minus a. That's something you may want to remember. Because if I have in my expression a minus b and the other one is b minus a, that's all I have to do is just factor a -1 out of one of them, and they would be exactly look alike, so I can reduce them or factor them. So let's take a look at the next one, part B. All right, here we want to simplify this. I have p minus 2. This is prime already. But at the bottom of the fraction, you have 4 minus p squared. Okay. Before I use the difference of the square method, if I factor a -1 here, okay, what times -1 give me 4? That must be -4. What times -1 give me minus p squared? That would be plus p squared. So you notice that I can switch these two around. -4 plus p squared, the same as p squared minus 4, same thing. But if I write it as p squared minus 4, if I factor this using the difference of square, now p minus 2 and p minus 2 reduces, and that's how you can simplify this. And keep in mind that -1 is part of your final simplification here, that you should include that as a final product here.